Okay, so today we're going to take a look at the beginning of Unit 8, which is over more theorems of triangles. We're going to kind of look at what today we're going to look at mid-segments, but then we'll take a look at what side links will actually form a triangle. We'll take a look at the Pythagorean theorem and more to do with that in this unit. So, as I've already mentioned, the first thing we're taking a look at today is the mid-segments of triangles. This should be a fairly short and simple section. So, I've pulled up GeoGebra, which is a website that allows me to do a lot of math-related stuff. I've just went ahead and made a basic triangle in which what I can do is I can take and kind of move these points around as I see fit. So, what we're taking a look at today is what is known as a mid-segment. And to form a mid-segment, what I'm going to do is I'm going to make two midpoints in my triangle. So I'm going to take two sides of my triangle and form the midpoint. So let's say I find the midpoint of AC and the midpoint of AB. Hopefully you remember that the midpoint is the point that is halfway between these other 2 points. So what we would end up with is that AD and CD would be congruent to each other. They should be the same measurements. So to actually form the midpoint, or the mid-segment, what I'm going to do is I'm then going to take a segment and connect those two midpoints together. So now I have formed this mid-segment DE. And so the good thing about GeoGebra is that now I can kind of take and move this around, and what's happening is that these midpoints are still always going to be midpoints, and that mid-segment adjusts as I kind of move that stuff around. So we have two properties that we care about with mid-segments. The very first one that we have is that when we form a mid-segment, we get parallel lines. So DE, which is my mid-segment, so DE is parallel to one other side of my triangle. So DE would be parallel to segment CB. So anytime you form a mid-segment, the mid-segment will be parallel to one side of your triangle. The other property is that the measurement of your mid-segment and the side that it is parallel to are special. So if you find the measurement of DE, it's 5.16, yada, yada, yada. If I find the measurement of CB, it's 10.32. So what we have is that the mid-segment, so DE, is going to be equal to 1/2 the measurement of CB. So the mid-segment is always half the measurement of whatever side it is parallel to. And we can sit here and adjust and move this around. And so like we have 10.16, 20.32. 12.6, 25.24. Sorry we have these crazy decimals, but 10 to 20. So this is always true. So that's when dealing with just one of my mid-segments. I can also go ahead and just construct the other midpoint of my triangle, and then we'll go ahead and connect all of these segments together, all these midpoints. So when we do this, what we've done is now we've formed what is known as a mid-segment triangle. But the important thing is that EF, which is this side, is parallel to AC, and if we were to measure EF and AC, we would find out that EF is half the value of AC. We would also have that AB is parallel to DF, and the DF is half the measurement of AB. So that covers majority of what we're looking at. 5-1 triangle midsegment theorem says that if D is the midpoint of AC, E is the midpoint of CB, then DE is parallel to AB, and DE is 1/2 of AB. So midsegments are parallel. They are also half of the side they are parallel to. So we'll just run through some quick examples here. So we want to find the measurement of UV. Well, I know that U is a midpoint. I know that V is also a midpoint. So this is the side that is parallel to my midsegment. So this should be double whatever this is. So that means that UV should be 3 units. So now I want to find the side length of BD. Well, we have a midsegment yet again. The midsegment is 8. So to find this, all I need to do is just double that. So that should be 16. Here are 2 examples. Take a little bit of time, see if you can work out what the correct answer is. And I'll just go ahead and have these as Edpuzzle questions. So obviously this one should be 3, and then this should be 8. So here's a slightly more complicated one, in which now we're working on algebra. So CB is equal to 1/2 of WY. So the midsegment is half of whatever it's parallel to. Well, I know CB is x plus 15, and that's equal to half x plus 21. So now I have this equation in which first instinct for a lot of people would probably be to go ahead and distribute this half through the set of parentheses. That's the first thing that most people would want to do. But if I do that, what's going to happen is I'm going to introduce fractions inside of this because obviously x divided by 2 is going to be a fraction, and then 21 is not a even number, so you're going to get another fraction. So what I'm going to do instead, to get rid of this half, I'm going to multiply both sides by 2. When you multiply both sides by 2, this a half times 2 cancels out. So you end up getting this, and I'll just leave this 2 times x plus 15 for right now, and then we'll deal with that in a little bit, is equal to x plus 21. You might be asking, well, why would I do that? Purely the reason is that I just don't want to deal with fractions. So by multiplying by 2, you cancel out the fraction. Now I have the 2 over here, but that's fine because now I can actually distribute this through and get 2x plus 30. And I'm much happier dealing with that than dealing with x over 2. And so now I just have an equation that I'm just going to solve, so I'll go ahead and subtract x from both sides of our equation. We get x plus 30 is equal to 21. Subtract 30, and you get x is equal to -9. And now you might be going, well, wait, how is x -9? That doesn't work. Well, luckily enough for us, x isn't the measurement of the side. X is just some variable, so we would take and plug that back in. So you get -9 plus 15, and you get 6. And then we plug in a -9 plus 21, and we get 12. So now CB is 6, WY is 12. That math checks out. My midsegment is half of the side it's parallel to, so x equals -9 should be the correct answer. So here's another one. We'll go ahead, and so previously I've been setting everything up as the midsegment is half of whatever. We could also go ahead and say, well, if I take my midsegment, KJ, and double that, it should be equal to the parallel side. So if you multiply the midsegment times 2, it's equal to the side it's parallel to. So we get 2 times x plus 18 is equal to x plus 28. So I've set up the problem. Go ahead and work this out. Find out what x is, and then this will be another question for you to answer. So obviously the first thing I want to do is go ahead and distribute. So we get 2x plus 18 times 2 gives you 36, which is equal to x plus 28. We'll go ahead and subtract x from both sides. You get x plus 36 is equal to 28. We'll subtract 36 over, and you get x is equal to a negative 8. So now, to actually make sure that this is correct, we would take this negative 8 and plug it back in. So you get negative 8 plus 18, which gives you 10. You get negative 8 plus 28, which gives you 20. 20 and 10, those check out. Midsegment is half of whatever it's parallel to, so x equals negative 8 should be the correct answer. So here's just an example of a mid-segment triangle in which what we can do is we can go through and state all the sides that are parallel, or what would be half of what. So I would know that side NM, or the mid-segment NM, is going to be parallel to TR. We also have that NP is parallel, so this is parallel to SR. And then finally, MP is parallel. This is parallel to the top, so it's parallel to ST. Another interesting property that we have with these midsegments is that I know that this is half of this. Well, what that means is that these segments are actually congruent to each other. And then we would have this segment would be congruent to these two. So SN, MP, and NT would be congruent segments. And then SM, MR would be congruent with NP. We already know that SM and MR have to be congruent to each other because M is the midpoint. But because it's, cut in half to get your mid-segment, those would also match up. So you end up with a bunch of congruent segments when you have this. So I think for the most part that covers mid-segments. We'll have an assignment over that. If you have any questions or whatever, just let me know.